And more. And even more than that.
Fantastic.
Okay? So, at the top, suppose, ready? Okay, suppose that DHTT represents the rate that the height of a tree is changing each year. Now, they did not put units, so I'm going to assign units to it. We're going to say inches per year, because it's telling us the rate that it's growing. Okay, so let's say a number of inches per year. Okay, then they tell me DHTT is 2. So what that means is each year that goes by, the height of the tree is changing 2. Yeah? So sketch a graph of the function. Let's do that first. So bam, bam. We're going to put, this is a graph of, bless you, DHTT. And it's measured in, what are our units that I just gave you? Per year. And then on the x-axis, we're going to put time, which is going to be measured in years. Okay? Now, what did it tell me my function is equal to? DHTT equals 2. So we'll say 1, 2, there's DHTT. Okay, so it says, sketch the graph of the function and evaluate the integral from 3 to 7. Now, 3 to 7 integral, remember that means area. Now, specifically, I'm only going to shade between 3 and 7. So we'll say 1, 2, 3, 4, 5, 6, 7. And then I'm going to shade between the function and the x-axis. This is just like we did on Friday. Okay, so I'm shading all the way till 7. So I would say the integral from 3 to 7 of DHTT is equal to that area. What is the base of that rectangle? Okay, rectangle. So it'll be 4. Now let's include units. 4 what? 4 years multiplied by, and then what's the height? 2 what? Inches per year, right? Okay, well 4 times 2 is 8, and then what are my units? Inches. What happens to the years though?
Oh, they cancel out.
Yeah, these inches are on top, or I'm sorry, these years are on top, these years are on bottom. They're going to cancel out. My result is going to be inches. Now, I want you to think back to if I had inches and I took the derivative, what would I get? Inches per year. What would the second derivative be? Inches per year squared. Okay, but if I have inches per year and I do an antiderivative, I get back to just regular inches. It's because these cancel out. Okay? Now, we're going to interpret the meaning in terms of units. Okay, so what that would mean is over t equals 3 to t equals 7 years. That's a 2. So from t equals 3 to t equals 7 years, the tree's height would have changed 8 inches. So when you do an integral, you're saying how much that antiderivative, whatever it is, how much it would have changed. So over 3 to 7 years, the tree's height increased positive 8 inches. No, you don't have to. Now, remember that integrals can also come out negative. So what if an integral had come out negative? It would have decreased 8 inches. Does that make sense? Okay, so let's do the next one. Okay, so it says, suppose DFDT represents the rate that temperature is changing on a certain day when degrees is measured in Fahrenheit and time is measured in hours. So, set up your graph. We're graphing DFDT. Now, quick question, what would be an easier way for me to write DFDT? Could I call it F prime? Okay, that's the same. So you should know in your mind those are the same. So for example up here, if this was DHDT, what could I have called that instead? or h prime of t. Okay, so just keep in mind, those are just different notations for derivatives, but they mean the same thing. Okay, so then it says I'm going to do a half f plus 40. Now I want to change that to be negative a half f plus 40. Okay, so let's sketch what a graph of that looks like. Where does it start? 40. And then if it's minus a half, what's my slope? Down 1 over 2, down 1 over 2. Now, I'm going to be lazy. I don't want to count down 1 over 2 that many times. So think about it. It's a function. Where am I going to shade until? 12. So rather than me counting down 1 over 2 12 times, I'm just going to plug in 12. And it'll tell me how tall it is on my graph. So we'll say 12 is here. And we want to know how tall that point is. So then I would just plug in negative a half of 12 plus 40. Well, what's half of 12? 6. Negative 6 plus 40 is 34. Very good. And then we're ready to shade. Now, I forgot to put units on my graph. I'm going to do it now. 8, or f prime, is going to be measured in what?
F prime?
Uh-huh. Okay, read it. Okay, so Fahrenheit per hour. So this is degrees Fahrenheit per hour. And then what would time be measured in? Hours. So that's a degrees Fahrenheit right here in case I made my circle a little too big. Okay, so we're shading, 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 shading. Okay, what shape is that? Trapezoid. So the integral 0 to 12 of h prime of t dt equals, okay, remember that's the same as dh dt, it doesn't matter. Okay, I do 1 half, base 1, how tall is it? 40, plus base 2, how tall is it? Give me the y value, 34. And then multiplied by the height, which is 12. 40 plus 34 is 74. What's half of 74? Okay, and then times 12. Don't know the answer to that. What is it? 30? Okay, cool. 444. Now, let's talk about units. If I multiply degrees Fahrenheit per hour multiplied by hours, what am I going to get? Degrees Fahrenheit per hour multiplied by hours, I'm going to get what? Degrees Fahrenheit. Okay? So what that means is that would be the amount that the temperature would have changed. Okay? Yeah, so the world exploded, everyone's dead, sad day, okay? But you get the idea, okay? But if I had degrees Fahrenheit and I took the derivative, I would have gotten Fahrenheit per hour. Second derivative would have been Fahrenheit per hour squared. So it makes sense when going backwards that you're pulling the per hour off because it's area. So when I multiply the units, it cancels out the hours.
Did you make the question?
I did. I just made it up. Yeah, it didn't really make sense.
Bro, that's like the temperature of hell.
Yeah, it is. It didn't really make sense, but you get the idea. Okay, so let's do. If Q is in units, then dq dt would be in units per time. And then d squared q dt squared would be units per time squared. So I want you to think about if I do an antiderivative on units per time squared, what would I get? Units per time. What if I integrate units per time? I just get units. Okay? So let's do this one now. So v of t, the graph above shows the velocity of a squirrel. Boom, velocity. Okay, then it says it's measured in meters per second, running across the power line. Find the integral from 0 to 4. Okay, so first thing I'm going to do is I'm going to find the area. 0 to 4, I'm shading, shading, shading. What shape is it? Okay, 1/2. How long is the base? 4. How tall is the height? 1/2 4 times 2. What do I get? 4. Okay, now why is it negative? Because the area is where? Okay, the area is below the x-axis. Now, I want you to assign units. This is meters per second. I'm multiplying by seconds. What am I going to have left over? Meters. Okay, so here's what that means. Over 0 to 4 seconds, how far did the squirrel go? 4 meters. Which direction? To the left. So the area tells you how far it went, and then the symbol plus or minus tells you which direction it traveled. Okay, so I would say over t equals 0 to 4 seconds. Squirrel moved 4 meters to the left. Okay? And that would be you like explaining what you found. Okay? Alright, now look at the next one. 4 to 10. 4 to 10, fa la 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 la, you're shading between the graph and the x-axis from 4 till 10. What shape is the purple? Trapezoid, so 1/2. Base plus base times height. How long is the bottom base from 4 to 10? 6. How long is the top base from 8 to 10? 2. What's the height? 2. 6 plus 2 is 8. 8 times 2 is 16, but then cut it back in half, it's 8. But it's positive 8. What are my units if this was meters per second? Now it's regular meters. But which direction did it travel those 8 meters?
To the right.
To the right, yes.
Is the area of the trapezoid always just going to be the base plus base?
It's base plus base multiplied by height, then cut in half, yes.
Oh, okay. No.
Okay, cool. So then from there, we would say over t equals 4 to 10 seconds. The squirrel traveled 8 meters to the right. Okay? Alright, one more left. See if you can do it. Integral 0 to 10. What would I do? You'd add your, remember this is one of your rules, 0 to 4 plus 4 to 10. So if this one was negative 4 and that one was 8, what's my?
Just 4 to the right.
Just 4. And it's positive 4 to the right. Now, that would be your net change. Okay, have you guys used net before? Like net profit, whatever, blah, blah, blah. Okay, so what that is called in physics and also in calculus is your displacement. You guys heard that before? Okay, so your displacement is overall how far you moved and where you ended up. So my particle ended up 4 units, or my squirrel ended up 4 units to the right of where it started. Now, can displacement be negative? Yes, what if it had been a negative 4? Then he would have ended 4 units to the left of where he started. Okay, now let's talk about distance traveled before we turn the page. So, displacement is where I am to where I ended. Okay? Distance traveled, think about this scenario. Okay, it's Saturday morning. Miss Joyner's laying in her bed. Then she wakes up, goes and runs 20 miles. Okay, then I get back in bed. What's my displacement?
0.
Does that mean I didn't go anywhere? No. How far did I go?
20 miles.
20 miles. But I went 20 or 10 forward and then 10 backwards. So they canceled out with each other, put me back in my original position. So in this scenario, distance traveled, you take the sign off, you just count everything as positive. So for my squirrel, if he went 4 to the left and 8 to the right, what's his distance traveled?
12 meters.
12. Very good. So I'm going to put up here distance traveled is always positive on each sub-interval. So it doesn't matter if I go the same distance forward and backwards. Okay, they cancel out for displacement. They don't cancel out for distance traveled. So turn the page and we'll write your formal definitions for those. So in total, your squirrel went 12, but his displacement was 4. Okay, are we good to turn it? Yes? Okay. So here is the difference at the top here. When you want displacement, you are going to do a regular integral of velocity over the time that you care about from A to B. How can I take my integral and make it always positive? What symbol means that? Absolute value of velocity. So a regular integral, your forwards and backwards can cancel each other out. So this is going to tell you the directional change in an interval. Versus distance traveled is the sum of the distance traveled on each subinterval. Okay? So this should not be hard as long as you pay attention. We got 2 examples, then you can work on your homework 3. So you have a bug, he's on a vertical wire, says the velocity is given in the chart, v of t. We're going to say he's doing centimeters per minute because it doesn't say, and we'll put minutes here. Okay, so part A, when is the particle moving? If he's on a vertical wire, let's change this to down, and let's change this one to up. Because technically you can't be going left and right if you're on a vertical wire. So when is he going down? How would I know the answer to that? This is velocity. Below the x-axis, very good. So v of t needs to be less than 0 or below the x-axis. When does that happen? 6 to 8. Okay, when will my bug be traveling up the wire? From 0 till 6. That you should already know how to do. Okay, next question. When does the bug change direction? 6, because why? Because my velocity changes sign. Now, then they ask me if it's a relative min or relative max. How do I answer that? I look at the direction of the sign change. At 6, how did it change? From positive to negative, that means it would have gone up to down. That makes it a max. So I'm going to put plus to minus, therefore max. All of that should look familiar. Next, I want acceleration. How do I find acceleration if this is a velocity graph? Okay, acceleration is the derivative of velocity, which is what in the graph? The slope. Okay, so if I have velocity, acceleration, that's still the slope, just like last semester. So at 1, I want a of 1. Okay, well, 1 is here. Remember, you should always use pretty points to count your slope. So I'm going to count my rise over run from here to here. How many do I have to rise? How many do I have to run? So it's 3 over 2. Next, I want the acceleration at 3. Acceleration at 3. Look on your chart. 3 puts me here. Okay, what is the slope of the line segment at 3 if it looks like that? 0. My acceleration, if it's flat, my slope is 0. Okay, so I'll put here a flat slope. Okay, a more academic way to say that would be horizontal, but you get the idea. Okay, what about, I wrote acceleration at 4 is next. Why is it D and E? Good job. Okay, at 4, I have a corner. You can take the slope at a corner. Okay, D and E. Okay, because V has a corner at T equals 4. Okay, I can't take the slope at that point because it's a corner. Now we get to the new stuff. How do I find displacement? You just wrote it at the top. What do I do? Displacement, I do a regular integral. Yeah? Now, where do I want the displacement from? 0 to 8. Very good. So I'm going to integrate velocity from 0 to 8. And then how will I calculate that? I'll do the area. Now, before we do that, skip ahead. How will I do distance traveled? That's when you put the absolute value on there. So I do that. Okay, but you just have to remember the difference. Displacement, you're doing an integral. Distance traveled, you're taking the absolute value function and then integrating it. So let's do it. 0 to 8, shade your shapes. How many shapes should you get when you shade from 0 to 8? Okay, 2. You can break it up more than that, but all of this up top makes a what? Trapezoid. And then this guy down on bottom, that makes a triangle. So find the trapezoid area, find the triangle area. This one is 12. Okay, and then what about the little one? Yeah, 1 is correct for that. So if I want displacement, my area on top counts as a positive 12, but my area on bottom counts as a minus 1. 12 minus 1, what's my displacement? 11. Now, what does that mean? That means that at the end, my bug ends 11 higher than where it started. Make sense? So I'm going to write that. My end position is 11 centimeters above starting position. Because what did he do? He went 12 up and then he went 1 down, then his ending position is 11 above his start point. Now for distance traveled, what would my calculation be? 12 counts as positive, 1 counts as positive. He went 13. Because each of those counts as a distance, not including a direction. Okay, last 2 questions. Okay, it says, suppose the bug begins 3 inches above the wire. Find the position at 8 seconds. Here's what you do. Go up to the top here. We're going to make a little chart. What did it say right here? Where does the bug begin? At 3. So, at 0, my bug is at 3. When is my first critical number that he turns around?
2.
When does he turn around?
6.
6. From 0 to 6, how far did he go? 12. Which direction? He went up 12. What's his position at 6? 15. Okay, then from 6 to 8, what did the bug do? He went down 1. So if he traveled down 1, but he was already at 15, then where is he now at? 14. Make sense? So the area tells you how much to adjust his position, but you have to do it in little segments, okay? So let's come down here. My position at 8 would be 14 units above. At t equals 8 seconds, bug is 14 centimeters above the origin. Okay, last question. What's the absolute min position and the absolute max position? Well, look at your chart. What's the highest that he went?
3.
Okay, his absolute max is 3 centimeters at time 0. What is his absolute min? Oh, wait, hold on. I wrote that wrong. Absolute min is 3 at 0. What is his absolute max?
15.
It is 15 centimeters. It occurs at
2 to 6.
t equals 6. And then you should put units on here, so that'd be minutes and minutes. Make sense? Okay, we got one more like that, then you have hopefully some time to work on your homework. Okay, last one. Good. Alright. Says a particle moves along the x-axis, that means it's going left and right. Then it says the velocity is given in the chart, so this is velocity. Okay, then they tell you, read this sentence right here. The areas of the regions bounded by the t-axis in the graph from 0 to 3, 3 to 5, and 5 to 6 are 8, 3, and 2. That means that this area is how big? 8. This area is how big? 3. This last area is 2. Now, instead of giving you little geometric shapes, they're just telling you the areas of each of those. Okay? Then last sentence says, at time 0, the position is -2. So I'm going to circle that, put a question mark, don't know when we'll need it. Okay, part A, when is the particle at rest? And?
5. 0.
0. So, t equals 0, 3, 5. Justify. To be at rest, velocity needs to equal 0. Where do I have a relative max?
4.
Now remember, this is velocity.
Speaking.
Okay, at 5. And then what type is 3? 3 is a min. So I have a relative max at t equals 5. I have a relative min at t equals 3. I'm only going to justify one of them because we've already done this before. So because v of t changes, for the minimum it would be -2 positive. Okay, new stuff starts at letter D. Says, write and evaluate an integral expression to represent displacement from 0 to 6. What should I write? Regular integral from where to where? 0 to 6 of what function? V of t dt. Do I include positives and negatives or no?
Yes.
Yes. So the first 8, how does it count as? Because he went backwards. His next chunk of area was a 3, positive or negative? Good. And then 2? Good. Overall?
5. No, 7.
-7. So what that means is that at his end, his position was 7 to the left of the starting position. Okay? His end position must have been 7 to the left of his starting position. Okay, next one. I want to evaluate and write an integral expression to represent the distance traveled. What do we change? Still an integral. Still 0 to 6, but I have to put bars around my v of t. And then the signs, you're correct, we have to change that as well. So now, distance traveled, it doesn't matter he went to the left, how far did he go here?
13.
So here he went 8, then 3, then 2, adds to 13. And that's his total distance traveled. Make sense? Okay, next 2 questions. Find when the particle is farthest to the right. Find when the particle is farthest to the left. Okay, one of those is a max, one of those is a min. Farthest to the right, is that a max or a min? That's a max. Farthest to the left, what do they want? Min. So we're going to set up our candidates chart. What are my endpoints? 0 to 6. And then when were my critical numbers? 3 and 5. Now, remember that thing we circled? They have to tell you where the bug started for you to be able to fill this out. So go back and read. Yeah, right here. At time 0, the particle's at -2. That means my chart has to start at a -2. Then, from 0 to 3, I accumulated 8 units.
Negative.
So he went backwards 8.
Negative 10.
So he must have been at -10. Very good. Okay, then between 3 and 5, how many areas did I accumulate? 3. Forward or backwards? So plus 3 from -10, where am I at now?
-7.
Okay, then my last little chunk, I accumulate -2. But if I'm already at -7, where am I at now? -9. So, time, position. So, look at your thing. Where is the particle farthest to the right?
0.
-2 is the biggest. So we'll write absolute max is -2 at time 0. And then what's my absolute min? -10, when does it happen?
3.
Is -10 at t equals 3. Okay. Okay, then the last little part, you've done this before, but we're just going to review real quick. At time 2, is the speed increasing or decreasing? What 2 things do you have to check for speed?
Velocity and acceleration.
V of 2 and A of 2, very good. Velocity and acceleration. Now, velocity is my graph, so it's my y value. So at 2, I'm going to come up to my graph here. At 2, I would be right here, is my y value positive or negative? Negative. So I'm going to put negative because below the x-axis. Okay, how do I find my acceleration? What should I be looking for? Slope. So come back up, peek at your graph. My slope at this point seems to be going uphill. So if I have a positive slope,
Decreasing.
then it has to be decreasing. Very good. Because those are what? Opposite sides. Very good. Okay. Then look at the last question here. What about at 6? Look at your graph. Okay, I'm going to come back up here to the top. Okay, 6 would be here. What's my y value? V of 6 is negative. But what's A of 6?
Negative.
Also going downhill, so negative. And if they're both negative, then speed is increasing. Very good. Make sense? Okay, you have almost 10 minutes. So what I would do while you're thinking about it is the back page of homework 3. It's a question very similar to this. It's broken down into different parts. It's the very last page of homework 3. You have 10 whole minutes. Okay? Yeah. Am I good? Okay, so you're doing the last page right here. And then tomorrow is I Know What to Do day in your second period.